Hello and welcome back. Now the big moment, let's actually train our model. So let's go in here and say we got our model, say model.fit, and now we can simply fit the model using our train dataset. So basically the train images, which we have put in the right shape and normalized, and also of course the train labels. So let's say train images here, and then so also train labels, and then of course we can specify the epochs as well as the batch size. So let's actually say I'm going with epochs is equal to, let's say, 8 here for an example, and the batch size is equal to 32. So of course you can play around with this, use other kind of epochs and batch sizes if you want, but this time let's actually try that. Okay, let me run this and actually see I got my first epoch, and let's see how long it takes. Hopefully not too long, but you can see it's pretty fast actually, even though here it's only running on my local CPU, right? I don't have a GPU, I don't have NVIDIA option here. I only training on my CPU here, but it still works quite fast. You can see that the loss is pretty going downwards. That's fine, and the accuracy is going upwards. It's also fine, so it looks good. But of course, what is important to us is how well is it on the unseen data, so on the test data. So let's actually check that. Model.evaluate, let's just see, evaluate, and say test images, and also of course the test labels, like that. Okay, let's actually run this, and let's just see whether we get a good accuracy. So we get accuracy of 78%. So it's not too bad, but it could be better, of course. That's why I said I encourage you to try out more epochs, another batch size. Of course, you can also adjust the layers if you want, right? So add additional layers, which maybe some of them which I have not used. So you can also try out that to make this model better if you want, but this is totally up to you, right? Okay, say for instance, I imported actually global average pooling. I did not use it. I could use it here as well. Again, as I said before, it's really try it out yourself. Yeah, feel free to try it out. Try different spaces, because there's no really you always have to do it this way, right? There is no this is absolutely correct and this is false. It's really that's why it's so interesting also from the topic, right? So you can really dive in and try out different things, and that's exactly what I want to encourage you here. Okay, but this already is much better than, for instance, all the networks we had at the beginning, right? When we did the training with, for instance, the basic neural network here. And the great thing here really is that it worked very fast here, also on a CPU. So I think everybody would be able to follow along here with this video, even though you don't have a GPU, NVIDIA GPU like I don't have to have here, for instance, right? Okay, so we have this as well, and then finally, of course, we can, if we are say that model is for now, that's fine, that's okay, then we can simply download the model, right? So you can simply then save this model, so simply by running model.save, right? Model.save here, this command, and you specify then a file path, for instance, fnet.h5 for the model weights, and then you can download it. If you run this, you can download it. I will not run it right now, but simply, as I said before, if you want to save it, and I encourage you, of course, to save it, you can simply download it here. So let me actually give you a short update. I couldn't resist, so I actually used here also the global average pooling just to try out whether I get a little bit better in considering the accuracy, and then I rerun the model here, and you can see now I got 80%. So as I said before, it's really up to you to try out different hyperparameters, like different kinds of epochs, batch sizes, and also different kinds of layers like we did here. So all we did here is adding this global average pooling in between those two steps, right? So you can try that if you want. You don't have to. You can also add additional dense layers, dropout layers, and so on. It's totally up to you, okay? So that is that. And now you can save the model, as I said before, if you want to save it. And then finally, of course, we can also take a look at one of the predictions and make sure that our model is able to predict anything. So let's actually first import something. Let's say import matplotlib pyplot as PLT. Okay, so we got this one here, and then we also want to plot inside the Jupyter notebook in my case. So simply say matplotlib inline. Okay, it's a magic command. That's why this percentage figure here, and it simply allows us to plot visualizations within the Jupyter notebook itself. And then I will also import Pillow. So just in case you have not installed it, you need to install Pillow. It's a library also for visualizing something. So that is why I say simply I want to from pill import image. Okay, you don't have to use Pillow. You can use it and follow along, or you use matplotlib. There's also an imread, I think, or other kinds of well, in this case, libraries which are available to visualize images if you want. Okay, so from Pillow import image, that is that, and then you can simply say image. Again, you need to install Pillow. I think it's pip install, and then I think it's Pillow actually, Pillow. Just in case you run into an error, of course you can also Google it. Might be capitalized like Pillow. I'm not so sure about that, but you can try those two options if you want. Otherwise, of course, feel also free to ask, but probably you're faster if you simply type it in Google. Okay, so okay, image, and then I say simply equals to image, image.open, and then I need a file path. I already have one, so I simply put in the file path here. No, I don't have one. Okay, so just a second, I go to this image folder, and you can see here I got the images here for the different kinds of well, rock, paper, and scissors, as we have here, the datasets, and I provide the link so you can download those as well if you want. One thing to keep in mention here is these are PNG images, and those images have actually 4 color channels. So this is something I was struggling with. So we first need to convert this into RGB, so into 3 color channels, also to visualize it and also to plot this then in, or basically provide this as an input to a neural network and then make prediction. Okay, so I take this one here, for instance, as a first one, and then I go back to the model here, and I can simply say, here at first I want to take a look at it, so let's actually read it. And okay, we got our image here, and now if we call this image here, and of course, as I said before, I want to convert it, so .convert, and here we specify we want to convert it to RGB, okay, 3 color channels here, like that. And then we can run this, and we got here basically our rock, right? So this is just if you want to visualize the data. So open the image and just make sure that you convert it to RGB. That simply means that the image has then 3 color channels, which is exactly the way we need it for our model to make a prediction. Okay, so we got this. And then I can simply here now actually prepare the data, because currently it's an image. We need to prepare it a little bit. Remember, we need to resize it to have the right size. So we can simply say image is equal to image.resize, and then you specify 32 by 32 pixels. Be aware that we have 2 parentheses here. So we got the image, and then we simply say x is equal to, and I say np.asArray. AsArray allows us to convert the image into an NumPy array. So image here. And then we can also say x is equal to x.asType. We want to convert it to float 32. And then, of course, finally, we will also want to normalize it. We say x is equal to, and say, or actually divide it by equal to, and say 255, right? So these steps we're going to do here. So it's basically the pre-processing of the image itself. You can also put it in a function if you want. So def pre-processing, then the image, and then you do the resizing, converting to array, asType float 32, and divide it by 255. You can also do it in a function if you want, right? But this is basically, all this is the pre-processing step. So pre-processing, images, or image for predictions, okay, or for the model if you want. So as I said, that's what we do, and that's basically kind of similar to what we've done here, right? So we also here put this into the right size here. We also convert it into a NumPy array in here basically. Then we convert it into a float 32 data type, and then we simply divide it here by 255 to normalize the data. That's basically the same what we do here for our test example. We can run this, and then of course if we take a look at the shape, x.shape, this image should now have exactly the shape we need. So 32 by 32 pixels, 3 color channels. Okay, so that's fine. So far so good. And now we can simply, or need to do one more step here, because we don't have a batch now, we only have one image. And whenever you have one image, then the network requires you to add one additional dimension. So at the beginning. So instead of 32 by 32 by 3, what we need is a 1 by 32 by 32 by 3. So basically 1 specifying that we only have one image. And in order to do this, there are various ways to do it, but we will use NumPy. So we simply say x is equal to np.expanddims. Expand dims simply referring to expand dimensions, and then we need to specify, okay, which array. The array is the x, and then we need to specify what is the axis. The axis is equal to 0 because it's the first dimension, right? The zero dimension if you want. So that we do, and now we can take a look at x.shape again, shape like that, and you'll see that now instead of 32 by 32 by 3, we got 1 by 32 by 32 by 3. So this is exactly the shape you need when you want to make a single image prediction with the network. Okay? So, okay, so far so good. And then of course we can do the prediction. We can simply say, let's say prediction is equal to, so model.predict, and then we specify in this case x. Okay, and we could take a look at the prediction if you want. So prediction, and we can run this and take a look, and you can see that this is basically what we get here. And you probably see already that this should be the biggest value here, the first one, and the first one is a rock. However, this is of course not something we want to present, or basically if you don't know that rock, paper, scissors is this order, we need to basically predict rock itself, right? So the name rock. So what you could do is you can use then some kind of, in this case, at first you can get basically the maximum of the class itself. So you can say CLS number. So the class number is equal number. Not really not good in spelling. I'm sorry. So class number is equal to, and you say np.argmax. Argmax allows you to return the maximum of the array, and in this case you refer to prediction like that. And you'll see that if we print this class number like that, we run it, you can see it's a 0. 0 simply means that this is the highest value of those three, right? So if the first one would be the highest value, this one here, then we would get a 1, second one would be a 2, and so on. So this simply allows us to give really basically the index of the prediction. So in this case, it's the first one, which is this one here, this 9.93, and so on. And we can work with this. Let me actually put in a new cell here. Of course, you can also write all of this in one cell. Just want to make it like that. And then I simply specify, let's say, a dictionary, labels is equal to, and now I simply specify, okay, the 0 should be a rock. Then the 1 here should be, in this case, paper. And of course, the 2 then, 2 should be equal to, so we can map it to scissor, okay? Scissor or scissors, something, rock, paper, scissors, okay? So like that, so we got the labels. And now, of course, if we say we want to print, in this case, then the labels, and from our prediction, which is simply the class number, CLS number like that, and we can run this now, and you can see now we get us an output rock, right? Which is exactly correct, because the image itself is rock, right? So the network was able to predict this correctly, okay? So that is that, and as I said before, what we want to do is, I have already done it, so I don't have to rerun it, but here you can save the model, fnet-h5, because this is the file which you can then use to load it back again, and then make predictions another time, okay? So that's it actually for this video. Hopefully that was interesting. Hopefully you were able to follow along. In case you got questions, of course, feel free to ask them. Otherwise, I can't wait to see you in the next video. Until then, best guys.